Okay, so I've got a sequence ready to go, which sounds similar to the one you described. And to begin with, I'm just going to go through the sequence as I would imagine it being presented in the classroom. There are different ways of presenting these, but I'm going to go through one and then try to point out the reasons we could predict in advance that this would fail. I'm going to teach you what we mean by the word quadratic equation. To start, this is not a quadratic equation. But this is a quadratic equation. This is a quadratic equation. This is not, sorry, this is also a quadratic equation, but this is not a quadratic equation. Okay, one thing to point out straight away, that is not a very good presentation. So physically presenting this in the classroom, that was probably a minute or maybe even more just to present 5 examples, to physically get them on the board. That's way too slow. This should take about 10 seconds. So something straight away is wrong with the presentation. 10 to 15 seconds maybe, tops. It took so long that towards the end there, I actually made a genuine mistake. I got confused in my own head about what I was presenting. So you can imagine what that is like for children who are sat there observing this, waiting for you to get to the point. Now, it doesn't have to be done that way. This same equations could be set up in advance on PowerPoint. You can flick between them. That would certainly make it a little bit faster. That's an option. But now you've got to do prep work in advance. You've got to get your PowerPoint slides ready. Another alternative is to not rub anything out. So you could just present everything like this. I'm generally not a fan of that quite so much as I prefer presenting things one at a time. I feel like if we have to present them all at once like this, something's probably gone wrong. And the reason I've written these up like this, so we can look at them now, is to see what has gone wrong and why, hopefully a bit more clearly. If we look at these first two examples, where we have this minimal difference between the negative and the positive, that might work. That might be okay. I've added this x squared thing, and now suddenly it's a quadratic. The x squared seems important, but I've also added this plus here, this plus symbol. So, but what impact does that have? We've changed some extra things here. Might have been better if I just added the two if people can forgive me using technically inaccurate words like add the two, but written a two there, maybe that would have been a little bit clearer. The next thing I want to point out is if we look at these, this is where I think it's guaranteed to go wrong. It's these three here, the positive, the positive, the positive. So I don't know what you wrote exactly, but you said you made them maximally different. So I've gone to a bit of an extreme. I've tried to make them very maximally different. We've moved terms around. All the terms have changed. And the difficulty of that with this particular sequence is just how much change there is and how difficult it is to keep track of. That's true even when we inspect them side by side like this. This is difficult. It is even more difficult when you present them the way I did, one after the other, only one at a time. So, our ultimate goal is to direct attention to exactly the thing that matters. So much change is taking place between these three. it's exceptionally difficult to see what is the thing that matters. So much has changed. And looking at it through the eyes of people who are relative novices at this, we look at this and we see quickly, we see three equations, we see uh, two expressions, one on either side. We see four terms, four terms, four terms here as well. We can inspect for which has the highest power. We know that that matters. Our attention is just automatically directed to the things that matter. To see this as our school pupils see it, you have to think of it in terms of there are 1, 2, 3, 4, 5, 6, 7, 8. There are at least 9 different symbols there. You can break it down even further into, you could call this 2 symbols each, 2 lines here. That's probably a bit extreme. They probably get that this is forming an X and so forth, but you have to think about it almost completely disintegrated rather than being chunked together into meaningful pieces. For them, this is a tremendous amount of noise here and here and here. I often encourage people to go look at Diophantine equations to get a sense of what this looks like for pupils. So, why did this go wrong? It was impossible for them to know what mattered, to know what they should be attending to know, to see what it was that was staying the same each time. This inclusion of the an x squared term, and also importantly, which complicates things even further, that the x squared is the highest power. So that's why I think we could predict in advance that this was going to fail. There's just too much going on, too